thank you very much for your endurance. This is the last session before the fun stuff starts, but I think you'll really like this session. If there's too much today, you can catch me on YouTube in a month or two, and there's always the handouts that have all these statistics. This is a very brief agenda. I'm just going to talk about the importance a little bit. Our benchmark suite, our hardware environment for doing benchmarking, the statistics, that's probably what you really want, and the conclusion. There are two engineers that I want to single out for really making this happen. Adarsh Banad, he's not here, but he built the framework for doing all these tests. And Michael Curtis, he is here, he took advantage of the framework to very much improve our performance statistics. So why do benchmarking? It matters because performance matters. And we want to get the best performance under all the different workloads that you might have in production. So we need to know about scalability and capacity planning. We need to have tools to help us optimize and tune our FHIR server. All of these things require measurements, and that's why you got to do benchmarking. We use these tools internally. That's how we developed, or Michael developed, Jamieson Advanced SQL, because he could measure performance and he could see how much impact he had. This also helps with hardware and infrastructure planning. You'll need that in production. You want to know a lot about your hardware configuration so you can get the best performance. And then continuous improvement. Benchmarking is not a one-time activity, and it isn't for InterSystems. We will continuously be doing benchmarking because it's the only way we could continuously improve the FHIR server. We're running our benchmark tests daily in an automated way. We generate like 450 pages of documentation each day telling us how our FHIR server is doing. Well, you need a benchmark suite because there's no one single FHIR test you could do to essentially understand your FHIR server performance. And there isn't an industry standard benchmark FHIR suite. One of the hard parts in developing FHIR benchmarks is we basically had to create it from scratch. A number of tests that looked at search performance, update performance, create performance, bundle performance, all of those count. So we need a lot of tests to really understand the performance of FHIR server. The other thing is you need to develop these tests so that you're really testing the server and not just some other property of the Iris for Health platform, such as caching. So we randomize the resource IDs specifically so we're measuring core database engine performance. And we get a lot of summary reports and graphs, and I'm going to show you these in just a second. And then also we capture a lot of definitions so that you know exactly under what conditions these benchmarks data were developed. So what do we do in a benchmark suite? Well, as I mentioned, there's various types of FHIR requests. In a typical production server, you're doing things like loading resources and bundles. You're doing basic resource requests, obviously, but you're doing other more demanding requests, like you're filtering for resources. You're doing resources with includes. Includes generates not just the primary resource, but other related resources. You're doing rev include queries. These can be very demanding in terms of FHIR server processing. And also complex include queries, where you're doing multiple joins. All of this can make a FHIR server slow down, but it's realistic in terms of what you're going to be doing in a production system. We also obviously are going to do write operations, so you're going to do updates and conditional updates, and naturally you're going to do create and post operations, basic post operations, and transaction bundle requests. So we're measuring all of these because all of them are part of a standard production server. Other considerations is that your test, we have to really understand the FHIR server performance under load. And so we use multiple threads to simulate multiple simultaneous user requests so we can understand what's happening under a lot of load. So we also use different loop counts to simulate different transaction volumes going through the server. Hardware and environment. Obviously, you've got to standardize on some hardware environment so you could do an apples to apples comparison. We're running these tests through the use of a Python script. But really what drives the test are all these JMeter container that's driving FHIR requests one at a time through a web gateway container, and that goes to Iris for Health, and ultimately the data is exported to a performance analytics server that we developed. This took a lot of time in doing this, but we now have a very robust infrastructure for measuring results. Here is our environment currently. This is using, we have two different environments, JSON SQL and JSON Advanced SQL, that I'll explain in a second. They're using about 112 cores with 224 threads. You can see we have about, our FHIR server database is about 72 gigabytes. Our benchmark architecture, okay, all the data is written in it's not cloud-based, it's written on a QD server. There has been some performance tuning, but not a lot. So we've done some optimization of global buffers. They are purged before each of the individual tests. So that ensures that the global buffer pool is in a cold state prior to every test. These benchmarks, I believe, will continue to improve with performance tuning, but there's still a lot of things we could do to even improve performance over the next year. The test data. We have a lot of resources that are loaded into the server, roughly about 10,000 patients for both search strategies with about 15 million resources. Throughput metric definitions. This is where it's very important to understand, what are you measuring? Well, the key measurements, and we measure a lot more than what I'm going to show you this afternoon. We measure the average resources per second and the average requests per second. I mean, normally you get more resources than just one per request. Depends on clearly the type of request you're making. But these are kind of the most important metrics. And also really the throughput, which is just basically how much data is coming in the response that you've asked for. I mean, you could ask for a request that might generate many, many megabytes. Clearly, those requests are going to go slower than that is just processing a smaller amount of data. So let's get into the heart of this, the benchmark statistics. What did we find? Here was our first basic test. This is the encounter by patient identifier. So we're going to put in a random patient identifier with each loop of this test, and we're going to see how fast can this FHIR server return data. And here's what we find. We have two different strategies. One was older in 2023.3. The other is our more modern strategy that we've developed, Michael developed, with optimizations for certain types of queries. Notice that in the blue, it's slightly faster, but we're getting back around 4,000 requests per second for this very basic test. If we look at how many resources, though, are coming back, we can see that we have 160,000 resources per second. So this is the capability using a thread count of 200 threads. That'd be like 200 simultaneous users hitting this FHIR server. How about observations? Well, each patient frequently has many, many observations. Let's try the same thing with a random patient ID again. And here you're seeing the average request is around, it's smaller, it's around 2,000 requests per second. But how about the number of observations per se? Here you're seeing about 200,000 observations per second are being returned with, again, a load of 200 user threads. Now let's get into more complex queries. These are the things that are really going to challenge a FHIR server. So underscore rev include. This is a definitely more challenging query. Notice the extreme difference here. So our older strategy in 2023.3 is only processing roughly about 20 requests per second. Notice now with our new search strategy in 2024.1, you're getting 2,000 requests per second. So we're really talking about 2-3 orders of magnitude here. And if you look at the resources in this complex type of query, rev include, we're getting over 250,000 resources with JSON Advanced SQL versus a very small number with the older strategy. Reverse chaining, the underscore has type query. This is also a very demanding type of query. So here, notice with just 50 threads, we're seeing roughly about 130 requests per second with JSON Advanced SQL, maybe 10 with JSON SQL. But again, with this very complex type of query, we're doing much better in terms of JSON Advanced SQL, roughly 8,000 requests per second. Again, this is a smaller thread count, however, in this slide, in this example. Now, what about really complex searches where you're going to have date comparisons, multiple different kinds of includes of different types? So you could really load this up and get a lot of joins here. This is going to be an expensive type of query. Well, it turns out that with 200 threads, the JSON and JSON Advanced SQL are roughly equivalent, about 1,200 requests per second. And the number of resources per second that they return, about 250,000 resources per second. And again, you know, this is under a fairly moderate sized load. I don't know how many in the audience use dollar everything. This is a very common kind of request. And you can see with JSON Advanced SQL, we could process roughly about 35 requests per second. This is again with a lower thread count, and the same with JSON. And even the JSON strategy does a little bit better, but we're talking roughly about 55,000 resources per second being returned. With create patient, which is a pure write operation, we see in this case with 200 threads that we're loading roughly 4,000 resources per second into the server. Conditional updates. Here JSON does better than JSON Advanced SQL, something that we're looking into. With JSON Advanced SQL, we're getting about 4,000 updates per second. We're getting roughly 5,500 with JSON. Loading bundles, a little bit better for JSON versus JSON Advanced SQL, 3.5 and 4 for JSON. And then here's the number of resources per second that we're able to load, 5,000 versus roughly 7,000. So that's a whirlwind tour of a lot of data. I want to give you some very important takeaways from all this. The benchmarking that we've done has taken a great deal of effort by our engineers. It has taken a lot of work to build the framework so that we could run these tests on a daily basis, so that we can measure on a daily basis any changes in the code of our FHIR server. And it really does need documentation of really not only the workload, but the hardware. And we have a lot of things in the future that we want to measure. So a lot of, this is not the end of different search strategies. There's the cloud environment. We have other FHIR tools that we'd like to benchmark. But this is our commitment to ensuring really the highest scalability and performance of our FHIR server under load. None of our customers have, at this point, talked about our FHIR server not being able to perform for the workload they've had in the field. But we're planning ahead because we know that FHIR servers are getting ever more data and they're getting ever more load. And so we can't be complacent about this. Our internal benchmarking is really paying off because JSON Advanced SQL was able to show really what would happen with optimizing our search strategy. But there will be more changes to come to improve performance in the future. So additional benchmarking tests will be reported in coming quarters. I'd say stay tuned for further developments. And I'm not going to go through these. You could look at this. We've covered all of these sessions anyway. But I wanted to open it up for questions and answers. So do we have any questions? I'm sure when you get home, you'll have plenty of questions. But that's okay. If you do have any questions in the future, my name is Patrick Jamieson. Just write to me. I'd be happy. And you do have all these slides in your conference guide, but if you need them, I will be happy to send it to you. And again, I appreciate your endurance and have a good time at the museum.
Thank you, Pat.